Hello and welcome to CS264. This is lecture 14 and this is lesson 3. I'm John Keating and today I'm going to talk to you about the Liskov substitution principle, one of the key solid principles that we've been looking at in this particular lecture and series of lessons. So what do we want to say about Liskov Lsp? Well, it's a substitutability principle in an object-oriented programming language. And the principle states that if S is a subtype of T, then objects of type T should be replaced with the objects of type S. So that really what this tells us in English, I guess, rather than the mathematical description here, is that a child class should not break a parent class's type definition of behavior. In other words, when we have a base class and a child class, so we have some inheritance relationship or hierarchy here, then if we can successfully replace the object instance of a parent class with an object instance of a child class without affecting the behavior of the base class instance, then it doesn't violate the LSP. And really that's what we want to be able to do, and the examples that I'll give you in this particular short lesson will show you how to do this. So we're going to continue with the examples that we had last time. We're going to change our shape class setup. Okay, I actually disliked many of the features of the class structure that we introduced in the previous examples. I didn't like that the shape class contained an instance variable for width for all shapes, for example. It doesn't make sense, really. It doesn't make sense to call it that way, and we shouldn't have it. In really, what I would like or prefer is that shape handle their own descriptors, their own properties or attributes. So if we had ellipses or polygons, then we'd have to change shape anyway. So we're going to do that now here first. So what's left then? Well, we just have an abstract method. So if we just have an abstract method in the abstract class, then the shape in the model only has an area calculation. So it's behavior, not structure. So we can replace the shape class with an interface. So instead of shape, we look at iShape. So we're going to do that before we do anything else. So let's set up the shape interface. So I have this public interface shape here, and I've set this this behavior I'm saying, is get area, because that's what we want to be able to do. Now, ignore this stuff for the moment, please, because I have a second example of LSP that I want to talk about afterwards. So now, anyway, we have this iShape. We didn't have to have public here, but it tells us that any of the concrete classes that extends this base class or base interface called iShape need to implement get area. So we have a circle class. We've changed it now, and we can see that it inherits from iShape rather than shape. It has a radius which is handling its own internal properties here. And we can return the area, get area. So, the behavior as specified in iShape is being implemented here. Okay, and I have a little constructor here. And I've got some extra stuff in here that we have for later. We have this equilateral triangle, which also extends iShape, which is good too. And we also have a rectangle class. Okay, and this is new. Okay, so we included this rectangle class because I was thinking about it, and you might be thinking along these lines as well. Say, well, we want to introduce a rectangle class and we don't have it already. So let's create this rectangle class. And it has a height and a width. Again, it handles its own properties here. And now we have a get area implemented, and we have a constructor. So let's think about squares. We could, in fairness, erroneously, as we see later, think that, well, squares are just a special kind of rectangle. So let's actually have square extend rectangle. So we're changing a class hierarchy here for us, and so we have a width and a height, but this time we're going to ensure that with a square, that the widths and heights are always going to be the same. Okay, so we're overriding the width and height, which were virtual properties, methods, getters, setters here in this particular class hierarchy. So we're happy enough with that, and we've done this. And then we have a side as well, which we have because we talk about sides with the rectangle, and we have our square. So we are able to say that our square constructor calls the constructor for its base class, which happens to be a rectangle here, and we see that rectangle implements the get area, which is the height by width, so it extends iShape. So that's all fine. So we're happy enough, and it looks good. Okay, so we're also going to make an interface for the area calculator class, and we've changed the class, so it now requires some instantiation to make an actual object, so that when we call the object instances calculate total area method, it's just an alternative. That's why we're doing it this way. Okay, so we'll we try this and see how it goes. So here's our interface area calculator, and it just tells us the behavior should be that an area calculator should calculate the total area method. And we've done this, and so it's fine. And calculate the total areas before, there's nothing new here. We have our output formatter, which was as before. Now, let's see what happens. So when we want to talk about Liskov substitution principle, really everything looks great. So we can implement all the same examples before, including our rectangles. So we have a list of shape, and now we've got rectangles in here, circles, squares, and equilateral triangles. So really, a rectangle is just this square shape here. Okay, it's 100, 100. Okay, and again, I changed the circle so that it now works with a radius rather than circumference. So we want to be sending 50 rather than 100 through. So you can go back up and scroll up and have a look at that yourself. So the area calculator works fine. So this should run nicely. Now we want to start to get looking at Liskov, okay, Lsp. So we play nicely with the objects in their declared type. So we have a rectangle, which is a new rectangle. That's good. We can write out and calculate the area of the rectangle. And I'm just writing directly here. I'm not calling this output formatting thing at all. So we have a square S, which is a new square, and this should give us the area for this as well. So, and we write this. So that's good. Okay, so we expect that, and it just behaves as we would like. Now we're going to have a look at the problems with the design, because we want to try to replace the parent type with the child type. So here, for example, let's create a rectangle, which has a rectangle A, and then we're going to change the width of this rectangle. So instead of the width being, well, we're actually not going to change it too much. It's still going to remain as 100 here. So that's fine. So we write out the area of the rectangle, and we know what we should get. We expect it to be 20,000 here. Good. We're going to use this assert method within the debug package, which I have here in the systems.diagnostics. I've included here. And so we're checking to see, is the value that we get that we expect, does it actually appear? So that's what we're doing at this point here. Okay, at this point here. Okay, so that looks all good. So area should be 20,000. Now the next thing we do is we have a rectangle called rectangle B, and now we're going to call it a square. We're going to use a square to create this rectangle. Okay. So the child class is replacing. So this class here, okay, this declared class, it's going to be replaced with one of its children here. So we should be able to change the width of the rectangle again to be 100. So this essentially is a rectangle with 100 by 100. We're using the square class to do this. So it's a rectangle using square, and now we want to change the width. So we expect it to be the same again because we've just changed the width. So we expect to get 100 here. Okay, we expect to get 20,000 again. Again, we're doing this. What happens? Well, I can tell you in advance that this creates an error because the behavior has changed because we've replaced the child class, sorry, the base class with a child class. You know, the behavior, we just changed the width as we did last year, and we find that it's different. Okay, because the way we designed our square class up here, we had this work to make sure that all the sides remain the same. Well, that becomes a problem for us a little bit later, okay, because we're changing the behavior. Okay, so it should end badly for us. When we do the debug, we should get an error. The program should stop and tell us that, hold on here, the area should be 20,000. So we print the area, we should be getting 20,000. It doesn't. I know it doesn't because I've tested it. And we knew it wouldn't because we've set it up this way. Okay, so let's run these things and see how it goes. So let's have a look. And if, of course, if we get to this point here, it's basically telling us that we're breaking Lsp. So let's have a new terminal. And let's go into cd into Lsp. And of course, you'll be able to get all of this code yourself. Okay, I'm going to .NET run, and we should get all the issues that we expected here. So, okay, so our total area for the first example that we had up here, where everything was playing nicely, the rectangle area was worked out as we expected, and the square area was exactly as we expected. So that was our first printout. That was fine. We created a new rectangle, and that area there was as we expected. Yeah, it's 20,000. So now we created this new square here, and we got this 100. Okay, and the assertion failed. Okay, as we would have expected. Okay, because we didn't get the area that we expected. The first area, the area the assertion failed because the area should be 20,000 and it wasn't, it was 1,000. So that's not good. Okay, it's not good for us because it tells us that well, it's good as far as that, we get the error we expect, okay? And that was the purpose of this, okay? But what it's telling us is that we are replacing the base class with a child class and the behavior is changing. And this is what we see here. So this design of the square inheriting or extending the extending the rectangle, the bad idea. Okay, it's a bad idea, okay? And why is it a bad idea? So what do we learn from this? Well, we learned that we should not inherit square from rectangle because we're trying to have the relation between our abstractions to be the same as the relation between the objects in which they represent. So this is because, and according to our original article I mentioned from Uncle Bob in the last lecture, it's because the representative things don't share the relationships of things they represent. So our square class represents a square geometric shape, but it's not a geometric shape. It's a representation of a geometric shape. And similarly for the rectangle class, and the perceived relationship between geometric shapes are not shared by any of those representations. That's why we're going to have problems in our code. So in our example, we had a square object that started off with a different height and width than originally intended. We've done some work on synchronizing, but there were side effects. Okay, that's the thing, there were side effects. But if the base type is a rectangle, we don't really want this. So squares have a side and a height and the width. Okay, which is weird, right? So we can see we cannot successfully replace the object instance of the parent class with an object or instance of the child class without affecting the behavior of the base class instance. We get different areas computed, and that violates LSP. So there's a great discussion on that here in the Stack Overflow article. I wish you would click through and have a look. But the correct solution for square and rectangle is there should be siblings. They should both be children of shape and not have a parent-child relationship. Okay, so that's good. I hope we learned something from this. This lesson is going to be a little bit longer, I guess, than the 10 minutes, but I want to show you a second example. So let's say that we knew that we ultimately wanted to have 3D shapes as well as 2D shapes. And here we have our shape interface. So we could have a way to calculate the volume in addition to the area. Okay, sorry. Okay, so if we did that, then we would have to make this available here. We can have a double get volume, but we're going to say that because shaped circles are two-dimensional, they don't have a volume, so we'd have to throw this not implemented exception. Okay, in shape. Same with equilateral triangles. Same with rectangles. But if we actually had a volume calculator, we could create a cube shape which also implements our shape, and that would actually implement the get area and the get volume. And we'd have a volume calculator which works in much the same way as we had previously for the area calculator. You can uncomment all this and it will work just fine. And so if you work down here, you'll see that I can create a new cube, get the area and the volume, get a new square, get the area and the volume, and what's happened is that we'll have an issue because this will throw an exception because we can't catch something. This is also, shows us that this type of arrangement violates the LSP. And how do we fix that one? Well, we actually have two separate interfaces, one for area and one that handles the area and one that handles the volume. Okay, and we'll see that in the next lesson again on ISP as well. So I'm not going to take this and uncomment it, but if you uncomment this code here and uncomment the comments in the up here, all the stuff here, you uncomment these, and you uncomment the methods that are in the classes, and run this program. You will also get you will see some of the errors. Now you will need to make a slight change. You will have to comment out this one here as well, so that it doesn't generate an error for you. Okay, so you can comment this line as well. Then everything should run just nicely. So I'd like you to do that as an exercise for yourself. So we're doing two things that we've learned about LSP. You shouldn't have methods included as part of this interface that allows us that we don't implement or can't implement or throw some exceptions because it's not possible to implement them. And second of all, that we have we want to ensure that when we replace a base class with its child class, that the behavior is not changed in any way. So that's the Liskov substitution principle. Thank you very much for watching.